is here. Properties. Yeah, stream input, use device timestamps. Okay. This should be good. Maybe it's muted. Hang on. Okay, turn it up a bit. Hello. Noise gate. Oh, what did the gain reset? Alright, let's turn the gain up. I think we were at 15. Maybe this is too much. Hello. Hello. If I crank it. Wow, I wonder why it's so low. Weird. It's missing. I don't think it's powered off. This should be fine. 1 second. Yeah, it's working. Okay. Okay, I just had to re-unplug it. Okay, now we go in and see why. I don't know why it's so low. I had the gain at like plus 20. I don't know if we can just keep increasing it. Like that's 30. That seems like a lot of gain. But I don't know. Am I getting any background audio or anything missing from it? I'll turn it down a little bit. Alright, my audio should be now stronger than it. Yeah, it's weird. I don't know if anyone's listening, let me know what the audio is like.
Matt,
Yeah, what's up?
I need you for like an emergency.
Oh, okay. 1 second. 1 second. Let me mute. There we go. Alright, we're back. Let me know how the audio is. Our dog got into a fight with a rat and there was blood. Okay, and now this will do selecting debug. What are your tasks? Problem manager, must compile, reveal silent, presentation, group, okay, good. Launch editor, launch select scene. Alright, there we go. Should get that go. Launch boom. Test scene. Let's go. So embed, attach. Okay, making a cube. So we actually got back our mesh instance, so crate works. This brings us back a mesh instance. What am I working on? I'm not sure today. I'm kind of burnt out from work and stressed out. So this is a test project. Let me just make sure this is actually being created as a nodes 3D, not a mesh instance. This is fine. Debug test object. Okay, and use step. And what are we catching on? An exception that the node path, it's a weak reference to self. The AABB, I guess. Oh yeah, right. Okay, that makes sense. Oh yeah, because it's not out. So this debug test object. Let me just give it an export. Good evening. Hey Bix. Ouch, sorry for the burnout. Yeah, do something new and fun, exploring ideas. Burnout sucks 100%, but sometimes, burnout leads to something good. Best to switch gears, clear your mind. Yeah, exactly. Yep. Yeah, this will be just a... And I'll just grab the AABB. We're writing bad code right now, but that's fine. The music is... How loud is the music for you guys? I just gave my mate across the hall a very early build of what I'm working on. I'm trying to get some feedback on the movement. If anyone here is interested, I'm also happy to get feedback from others. Bill, not trying to self-promote, looking for feedback. You can link it, Bix. I won't get a chance to look at it here, but I don't mind you linking it. So I'll just kind of highlight here, just for Bear, what I was working on with this thing. So this is a little test space scene. It's kind of like a rewrite of the of some of the basics of ship behavior, like ship navigation, how it does steering, how it follows a path, how it applies movement, and these are also, just a lot of the ship navigation stuff is just resources. If Revere doesn't mind dropping a link, I'll give it a look at. Yeah, just drop it. Yeah, so the TLDR have what this thing is. It's just like a little setup, a mock setup of the universe with the right scale of the universe. I can't really link an EXE, even if it's from Godot. I currently have a web build. Yeah, you just throw it on an itch page. I don't mind it linking it. The issue is like random executables. It can get pretty sketchy. Unless I'm not so like, what would you call it? Like, test that and curate that it's, that's all good. So this is the behavior that I'm kind of testing here. So we have two NPCs that are like flying to a location. And then when they arrive, they need a path. So they need some type of dynamic Bezier curve. This is just a standard, typical Bezier curve, where in runtime they're given an approach. So every hangar is responsible for creating one arrival or departure, and because the ships are rigid bodies, their steering system has to honor the flight path. So they have the kind of sample. So if we know where they're going next, we can dynamically create and control how that Bezier gets kind of created to make sure that we're like bringing the ships out of the AABB of the station, right? So ideally, like this is just very primitive. Like we would obviously technically bend this towards their direction a lot earlier, but what's important in this particular test is that it can't fail. So the stability of the ships reaching A to B must not be compromised, regardless of which hangar direction is. Yeah. But as you can see, like this is a very primitive system right now, so we're sampling in advance of our forward direction points that have been given to the navigation system. Right, and then we have the kind of, control our velocity and control our speed input to kind of make sure ultimately that they get into the hangar, and then they're frozen. And then of course, once they've been there long enough, they get ready to take off. So we know we can create the curve. More math will need to go into the curation of how that curve gets generated. So like, the array of points. And then how they're going after me now because I'm too close to them. So that's what they do. They are AI. And then once I fly away, I'm too far out of their range, they'll continue on. So they're following the flight path. And the reason why this test project is set up this way is because in the main systems project, I just wish I could do more. I want to do this full time, I want to really push my ability to kind of keep at this. So let me show you how this translates into harder shit with the actual gravity flight system. So I put everything is together here and everything works, but fixing it to do what I want it to do is I need to experiment because this is what's happening now. We only want one. Move this over. So ships have the ability to align itself to a transform, to do a comparison, to track them, to do like everything you could think of a ship would ever need. So here we have all of our NPCs, and they have their own state, right? And they have their own seed, and they're going around doing their thing, right? The whole point of the game, they go get food, they go get water, and all of these are abstractly just 4 marker references in each system. This is called like an iService hub, and an iService hub has iService nodes as children. And those have types, right? So they're unified systems. So I can create another abstract thing, and it works. But see, so when the NPC's idle maxes out, their job is to get spawned into their ship, right? So they're going to their ship to fly from A to B. And now we're in ship world, right? Now we're being controlled by the ship. There's some very interesting behaviors that the flight system of ships do. One being that they align to a vector, they approach, they fight gravity. They're a pretty great system. Like I've well tested it, I guess you could say. But some of the behaviors of flight, it doesn't quite do yet. So when we get here and there's no spot, we're going to do a fly around. So that's what we're doing. We're arriving, we're getting a fly around. It's too much traffic here happening, so arriving ships are going to end up kind of turning around. But for ones that arrive and do have a spot, but notice that it is flying to match the transform. Like this one's coming in low, self-adjusting. And this is real dynamic steering. Like I'm not applying torque, and I'm not just applying like central force and central torque, right? I'm actually creating a rotational and transitional input, and I'm then driving those two vectors into the movement system. So in reality, these ships are actually being flown. They're being flown by wire. So the same, like they're just creating like a joystick direction. They're creating a pitch vector, and they're creating a roll vector, or like they're just pitch and roll. And their ability to, turn fast enough, or to move fast enough, or to do something fast enough is all in the stats of the spaceship. So a really bad NPC is just a very non-reactive NPC. They can't turn fast enough. They're slow on reacting. They're slow on the interpolation and application of the forces that they've determined are important to them. But the problem that I have now, right, is that this all works, but I don't want them to, when they arrive at their destination, we need to be smarter in how the ships fly into the station. That one ship didn't call the ball. Yeah, he didn't make it, right? So these little jittery lines, this is just physics interpolation. This is a debug version of, like, I guess, a physics interpolation. So the lines look really squiggly, but they're not really squiggly. Like the ship's input isn't. It's just a debug. So this can run forever. I've let this run for 2 days now. And, like in this scenario, the NPCs arrive, they get spawned, they go get food, they go get water, they do their thing, whatever. Systems and implemented, great. Well, here's now the problem. Right, we have very unique space stations. So this is version 2 of the space station, right? And my goal of this year is to get like visual vertical slice, right? So we have these space stations. They have modules, right? So a station has a collection of station modules. The station modules themselves have their properties, and they could be deep nested into the tree, but it can find them, right? So in the arm, we have these, these little where are they? Boop. Right, so here's like here's the little hangar section, and a hangar section is just a collection of hangars, and it could be visually any way at all. But as long as there is a hangar, we have we know that -z is the outward direction of the hangar. That's a good New Year's goal. Yep. So we know, like, always -z is out of the hangar. So we know that this transform, right, of the hangar is the source of truth for the hangar. So what you're seeing here in the hangar, right, for these little squiggles, this is an approach path. Originally, I wanted to artistically try to create the approach, the approach path, but I decided, well, that's not necessarily necessary, because in reality, right, and there's a lot of things here that I need to take into consideration when making these fly well, because the goal here is to kind of be able to create, these type of hangars are round robin. So you either go in or you come out, right? You go in, there's an animation, the little hangar here opens up and you get stored, and it can go through a full cycle, right? So it's like you get brought in, you hit this area 3D here, which is just a distance check. You have arrived, right? The arm attaches, but it doesn't matter if the arm attaches. This is an IK system. This is a fully independent system, right? This looks for a ship, On the ship, there's a node called an aim target. All ships have an aim target node. That it's just being referenced by the hangar system to do the whole fancy moving around the rail and attaching and all that crap. But it looks like there's a lot of complexity here, but there's not, right? There's just, you're either in the hangar or you're not in the hangar. If you're in the hangar and you are a ship, we use the ship reference, you know, and then we set the target, all that kind of stuff, right? So the problem, though, is approach and departure. So bigger hangars are going to have both, you know, the ability to have an arrival and departure lane. So think like nautical, right? Nautical blue or nautical red and green, right? Red and green coming in and going out. For these, it's either or, but either way, it's just going to be the same departure spline in reverse or not in reverse. The vector array is one way or it's the other way. But we need to determine when we are arriving, right? So we say we need like kind of a bounds, right? We just say, okay, here is the AABB of the station, of the total station, right? So what I would like to do, and I'm just going to use you guys as food for thought, right, is yes, we can recursively go through. I'm going to change this to something a little bit more chill. Anyway, okay. We can recursively build an AABB, right? Like because an AABB, at least on a class level, it's a bounds. It has everything it needs to determine whether you're inside bounds. So we would like to use the game object's total AABB space, which is what you're seeing here from Mesh Instance 3Ds in orange, right? So we want to use this to create a bound. And this bound would be used at a really high level. So, and what I mean by this, we can create like an octree-oriented spatial system where we can kind of break space up and create like a navigation system. That's kind of the goal, right? A massive navigation system that can kind of use, you know, like a quad tree to kind of, you know, are we within this volume? Are we conflicting with an object? Like that's like long term. Short term, the star system only has X amount of these stations, and other than real-time collision detection, like real-time is in like the ship's sensors detecting you and then navigating away from you, because they do have the ability, ships have a sensor system that totally can avoid things if they're detected. But at a massive level, where we mean like we just want to create a flight path, you know, we only need to know what objects are in the star system, right, and what those objects are, and what those bounds are. So like what we're solving for, or what I need to solve for, is from the Z of a hangar, we need to come out until we've passed the AABB. And the reason why it's an AABB and not just a distance, because I could totally use it. I could assume everything's a sphere, and that we could, you know, just kind of come out far enough that it would kind of be, you know, it would work. But I feel as the stations evolve and they get kind of higher and they become more of my envisionment of big spherical orbiting things, they will actually be more akin to squares, right? They'll have more big arms and they'll be more in their own space, like aligned to 90-degree angles. So I think ultimately, like a big square, AABB is ultimately going to be the more accurate representation of its volume. So we want our approach curve to pretty much come out on the Z minus or Z plus, because it's facing minus Z, you know, until we clear this bound, right? So once we're like out the distance of the AABB, then we need to know where that ship was going. So, you know, what is the transform? What's the target? Where do we know, right, on the navigation system that we're going next? And we get that point. And then once we've exited ABB, we now begin the Bezier curve, right? Which control nodes will be based upon, you know, orienting that departure towards where they're going to be going. Right, so the three, you know, it's pretty simple to explain, right? We bring them out so there's no risk of collision, and then we spline them towards wherever they need to go. And equally, once like each station has a big arrival area. Say we are the ship, right? If we arrive here, the same thing needs to happen in reverse. We're going to be given any random hangar. If it is, for example, the backside hangar over here, right? And I am where I am. It's the same thing. We're creating it in reverse. So we're coming back to here. And now we need to create a Bezier curve from here to us the perceived camera, right? But the control nodes of the Bezier curve must be outside of the AABB, right? And parallel. So if we're here and it's here, we know our plane. Like we know our plane of what is up and down of this curve. Like how our arch itself is in 3D space. And then, there's no risk of like having a line, like none of these would ever like overlap is the idea. And we can sample then whether the control nodes themselves, because a curve is only 4 control nodes. Any Bezier curve, 4 control nodes. We're always coming out from the hangar, so there's always that one transform reference, right? That vector 3 that's relative to the hangar. It's so easy then to sample the curves, like the flight paths themselves, their control nodes. It's like we're looking at 5 vector 3s to make sure that they're not conflicting with each other, right? We don't need raycast for that. We don't need, like, it's just math. It's just positional points in space, right? So the goal is we need to we need to create a stable system. Like, I know I can use the ship sensors, and like when the ship sensors detects it, we keep flying towards this objective and aligning to the objective. That's what it's doing, right? That's what it's doing now, right? But this has a cost, right? Like the flight, we want the ships to be able to behave in a very dumb sense, right? We preemptively create an approach path. We preemptively create a departure path. In this scenario, I can rotate this whole station in real time, and it would literally, I don't know if we're running it in debug mode or play mode. We're running it in, yeah. So like this is how dynamic this system currently is. Let me move this down, right? And if we go into the remote tree of our gravity testing, right? So here in the remote tree, and we're just going to grab in the universe star system that second space station. So you should see, I think it's, yeah. So if we go down to our rotation, not that one, I'll do this one. So if we go down to our rotation here, watch this. It doesn't matter what I do at the station. It's going to work, right? I can rotate it on any axis. Right? It doesn't give a shit. It's not limited to, you know what I mean, to the reality of where it could be upside down. But of course, there's some issues with the spawning, because I think the spawning is actually I think I just exposed something interesting, that we're not actually taking the we're getting the position right, but we're actually aligning the ship's rotation to match its parent when we spawn it. So I just realized that's actually a bug, but that's a small one. So as you can see, we have ships and they're very reactive. Like, you know, they independently do their own thing. Right? They're going to spawn inside these hangars. They're going to come up. They're going to take off, and they're going to go back, and and that's what you're seeing here. Like when they arrive, NPCs are going to spawn in their own private pocket. And so that's kind of what we need to get working, right, for the long term. But I'm thinking about just changing the way the navigation system is working, right? So anyway, that's why we're here in this second project, where everything is simplified, and we're kind of back to the basics. We still got a VJoy, still got the same input. It's fine, but. And that same thing, right? We're sampling. We don't ever want to go backwards. right? So system is kind of working as intended. We still got a lot of mass, so we're still like, you gotta realize, like I'm correcting for the mass of itself. So like I'm not actually steering it. I'm like correcting itself. I'm burning off that speed. Like it's interesting because when you're coming in really quickly and you need to slow down, and in this case, like you got to realize too, in my flight model for this project, there is no strafe. They can only steer. So this is like actually more rocket science than rocket science, I guess, because I never gave the AI the ability to strafe. If they could strafe and counter strafe on the, on the actual like linear force instead of like the angular, then they could behave a lot more stable. But dumb NPCs shouldn't be able to strafe. They should only be able to turn. Right? That's just a behavior that I want to have. I want to have 3 levels of ship AI, NPCs that can only steer. So as they steer, they'll kind of naturally drift, right? Because they're a rigid body. But they're not going to be hard to kill because that drift and momentum is going to be predictable. So they're kind of steering at you always. They're moving and they're steering at you, and they're kind of, they seem to be flying pretty random, but not really. They're only applying different steering angles to try to avoid you, but they're very dumb. And then on the next level, they can steer, so they actually are literally strafing while always facing you, and they are a lot more reactive and they're harder. And then in the 3rd level of NPC flight, that's when they're always taking their cross section into consideration. So what I mean by that, it's oh, hang on a second. Oh, it held the mission. Okay, there we go. Thanks. There you go. I just realized the bot actually stopped the message from coming through. So that's like the behavior, right? So in the advanced form, the NPCs are looking towards you. They're strafing, and they're rolling to keep their cross section away from you, and to keep their shield face. Like the weakest shield face is always going to want to be facing away, and it's their reaction of their. I like dungeon crawlers. Controls are WAD. Okay, cool. Right, so that's why the second area. I wanted something that AI could just consume, right? So hey, we just have the ship code, right? So everything, all we have is a smooth camera we're interpolating. We have a universal, so all we have here is ship input. This is our base node. This is a node-based system. I still like moving this into ref-counted base systems or something like that. Because what does this thing, what does ship input have? A movement direction and a rotational direction. That's it. It's creating direction, right? And then an actual player, right? So players themselves have player ship input. Player ship input extends ship input. And remember, what does it do? Its job is to just set these values, right? Movement direction, rotational direction. So a player ship input uses actual input, you know what I mean? Like the input of the game to drive those values, right? Rotation and movement. But then the navigation system, is also in reality then the navigation system. I can't tell if it's frame rate. Oh, you mean on Bix's game? Oh, it's intentional. Okay, cool. So the ship navigation is consuming ship input as well. So now we have this nice inheritance chain that works, right? Because a ship input, once again, its job is to create those 2 vectors. For a player input, then I can just extend that, and I can set up my little VJoy. We can set up the input, because ship movement itself, like the ship, regardless, it doesn't care what ship input is attached to itself. It could be that's the beauty now, is I can just create it doesn't matter if it's a player ship input or if it's a navigation ship input. I can cast it as an input, a raw one. I do have a little, if it's a player ship, I have a little, a bool that returns if the input is a player ship input. So just to know, hey, because we're making this dumb simple right now. There's zero. We're trying to create no abstractions. So that's the idea, right? We just have the ship navigation is actually just an inherited ship input, like the players, and then the ship itself, applies only those forces depending on that input, right? So handle input, check and see, use the movement direction, use the torque, get a rotational direction, and that's it. I like the art a lot, but the stutter makes me motion sick. It's supposed to be like that. It takes inspiration from old school crawlers like Wizardry. I get that. I just think it could be more smoother. I got to the end of the dungeon, but my eyes sort of hurt from it. Why were the old games stuttery? Or what was the intention of the old ones being lower? Right? Like, are they just intentionally lower? Like did they just have a low frame rate? Curious myself now. Oh, those one were choppy because they were like 2D. Oh, okay. I see what you mean. It's kind of like, was it Witch Haven? I remember like it was like an old Nintendo game. It was like a dungeon crawler. You had to kind of click and move. I gotcha. So it acts like it acts like the original games. There's just like 3 extra frames in the middle of the transition because we're 3D. Yeah, each tile was like hand drawn. I get it. It works well. Are there any enemies or anything? I'm just kind of just checking it out on another computer. What? Is there just ads on Twitch? Did I just get an ad on itch.io? I didn't think itch had ads, but apparently I think I did. So each tile was hand-drawn. I inserted random wait times during each part of the movement to make it more like what I'm wanting. I gotcha. Cool. Yeah, so that's where I am with it. And the idea, of course, like as I move this towards my ship itself, which extends rigid body, would have a movement component. So we have like this input component, we would have the movement component. That movement component wouldn't care about anything. It would just get the parent reference or get the past reference, depending on if you want to use like in here, like, you know, if I want to kind of do it in a more .NET style. But either way, like the movement component would get the parent as a rigid body 3D, and it would use, right, it would take in, you know, those inputs from the input. So that like it depends upon the input component and the movement component, and does its thing, right? So everything just kind of works on its own. So the ship's nice and clean, right? It's just a ship code. It's got a movement system. The movement system just needs to be past the input, and then you know, it's great. So like each movement is thus 0.4 to 1.2 seconds between the tiles. Are you planning on actually, like, is it still actually 3D? Is your goal going to be to kind of, you know, craft it all out in the same way, or do you plan to use like high fidelity 3D art for the actual like dungeon itself? It is actually 3D, cool. Because that's how we do it with our components, right? We have ship sensors. If it's not null, we're going to just subscribe to the ship's, you know, change, and any logic we need to do with the sensors, we can now do in the ship. And if, you know, there isn't any ship sensors, this never gets subscribed to, and it's not a problem. And it's only referencing another ship, you know, so there's no... But that's what I'm trying to figure out now, is what I want to solve. So I was in the middle of kind of creating... I'll close out this project. I might steal... While I'm in here, I'm going to steal my wireframe cube code. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Yeah, see, in this one, we just kind of made a default cube regardless, and we just scaled the cube, which is fine, but... I don't know why this format's so weird. Yep, thank you everyone for the feedback. I apologize for the eye strain. I could add like an eye fatigue option that changes it to like a single frame movement with the same like random time difference. So it just waits and then it kind of moves you. I just want to see what happens if we change the scale to be 4. Doesn't AABB ignore a scale? Let's find out. What happens to our objects AABB if we just mess the scale up? So in the editor, when we apply a scale to the object, at least the selection AABB is extended, but that makes sense for an AABB to not take scale into effect. Well, that could be bad. Let me just do that. Let me just vibe something real quick. Close out to the project. What happens if a get AABB has a odd scale? Say Z times 4. And then while we're waiting for AI, let's also just go in and look at the AABB again. Because it's a visual instance. So for a Godot visual instance, let's take a look at the Godot visual instance documentation real quick. So visual instance 3D usually is responsible for the AABB. So our AABB, which is our axis aligned bounding box in 3D space. So we can't use negative, that's obviously common. AABBs don't work with. Use ABS to get a non-negative size. Yeah, the cool thing about an AABB is you can actually get the surface, you can get the longest access, you can see, like, especially if you're if you're trying to figure out a shield and you want to know, like, you know, is the ship body wider or longer? Like, what's the, or for rendering it, right? You could use the AABB to scale the ship down to put it into a viewport, because you can use whatever the longest axis is as its scale, you know, basis that you're going to be basing things on. But what's neat about them is we can do an intersection, right? All we have to do then, because they're AABBs, is just do like an, you know, where they're, you know, returns the first point where the bounding box of a given section segments, you know. So if no, it will get null, right? So we can use these, and you can also merge AABBs, which make them really great. Returns the intersection point between the bounding box with. If the boxes do not intersect, it'll return an empty AABB. The box intersection is the edge, which returns a flat AABB with no volume. See that it has surface. Returns true if the bounding box width, height, and depth are all positive. Oh, cool. Okay, yeah, gotcha. Cool. Anyway, distracted. So AI in our learning. Alright, so the AA returns the local bounding box of mesh data, which is independent from the node's scale, rotation, or position. So that's what we thought. Over my head, right? So it's a local thing, right? So if you have a mesh scale by z times 4, AABB will return the same. It'll still return the original on-scale dimension, which is what we're seeing in the play mode. So the visual discrepancy in your debug, if you're syncing the position and rotation, but you're not syncing the scale, right? So we set the scale to match, then we'll get the same thing. If you want the AABB to appear in the scene, including the scale, you must multiply its local AAB by the node's transform. Right. Okay, yeah. Gotcha. Yep. That makes sense. Because the transform itself is also semi-normalized, or returns the new axis aligned. Gotcha. How to fix it, or you can make it match. I don't care about the visual. In this case, we actually want to know what the true AABB is. We don't want scale to affect it. That's the problem with, whenever you're kind of making that assumption. Scale is always the devil in 3D and in physics. So in our debug wireframe cube that we're kind of setting up here. Right, so we will do So what we'll do is we'll just actually get the AABB, and then we're gonna make it global. So we're just gonna create another one just for testing here. We're just gonna say this is our global AABB, which is gonna be our A dot global transform. I don't know why like Copilot is like doing like an X form. Like this is old. This is like from way back. Like, it's funny. Right, times our AABB. That's our global AABB, and then we're just going to send that into our debug. So now this will create a debug cube that uses our true global AABB, and we'll make it red. So this should be our true. Like we should return from our little factory pattern here. We have our little static factory pattern. And this is not. I probably wouldn't put it here in the class, but this is just. This is not meant to be great code at all, in any way, right? It's not. This is just make it work. Use the vibe coding. Don't like if you want some true advice, use vibe coding for this. Use it for planning. Use it for plan with it. Get an idea. Let it find the documentation. Let it look through the documentation. Let it look through the source code. Let it help you learn. Let it help you learn what we're needing. Ask it the problem. Don't ask it to code for you. I mean, you can. We do an absolute shit ton of vibe coding, like at work. But you have the ability to review it. But for learning purposes, this is how you should be. You have a Google right here in your editor, pretty much. And now if we go and just play this, right? It's going to launch, test, and stack trace, debug, go through, actually see what's happening. Right. So now we're returning our new cube, and what's interesting now is that we can actually go in. Right. So here's our debug cube. We're going to add it to the scene tree. So we're going to step over. There it is. It's been added. And what's cool is we can actually now see the new cube, and we can look for. We can see. Okay. Well, what's what is our actual scale. What's our basis? What's our AABB of this mesh? So our position, our rotation, and we're gonna just let it go. So now we should have. Oh, interesting. So it's correct now, but its position is interestingly not right. It's different from its bounding area. So let's. Right, so the global is whether a global transform, unless it's our local transform. Oh, maybe yeah. It actually is local. I'm an idiot. No, it's a global transform. Our global AAB will be our global transform. But we're actually feeding it into our create, which would be a local basis. Right. So let's actually set this up to run not multiplayer and in the game without input, embedded, just so we can kind of have some camera control. Yeah. All right. So we have our debug, but our AABB in this case is off. So we want to be able to create, artists should be able to create weird scale on all these things, but if we're systemically going to use it to, yeah, planning plus documentation, great for AI. Have it write markdown files for you to implement. And just to make sure that this is, just remove all this crap that we're not going to be using for now. All of this is very, very, I don't know what to call it. Like, I won't be able to do a lot of this on server side, right? Like, there's no meshes in the server build. There's nothing to get an AABB from. So my goal is to pretty much just eventually just have a tool that'll pull all this and create like an AABB and just kind of serialize it, save it out. So it only needs to happen one time. You have a volume that represents the XYZ of a station, but they're extremely good for like for editor tooling, and I want to be able to kind of use the total AABB as a tool script to go from the AABB to a bounding area based upon the global transform of the actual object. So if the AABB was like over here and it's like crazy, then we just have a bound, that is based upon the origin and has the right shape. Another really good use is if you want it to visualize, like in Unity. Let's say we had a spaceship, and the spaceship was like, I'm gonna make a capsule-y type one here, this is a free. So if we have a capsule ship, right, and you want to visualize a target indicator, like corners of a target indicator. So as the ship rotates, right, and say the ship is now facing you, right, the bounds change. You can use the AABB to dynamically be able to make the target indicator grow, right, with the on-screen menu or on-screen UI. So you, otherwise, like, you wouldn't know how big it is as you get closer to it. You know what I mean? Like, it's nice because it's a good visual representation of cross-section. So with an AABB, you can do that. So if we just, once again, just want to pass in the regular AABB that we've gotten and just see if it's center aligned. Close out Unforgiven systems. And it is. I wish it would like stay in the last mode, you know what I mean? Like just stay in 3D camera every time I hit play. So here, assume we get like we are. Y is the rendered ABB before the ship. Align to it. And I think it's because the origin is probably not considered centered. I'm just gonna change this back to the global AABB. And let's just put in the namespace here because I don't like having to use the This was an old one I wrote. We don't want to use this one. The rendering ABB behaves unaffected because the global transform time calculates world-align axis. When you apply the result to its own position rotation, gets it your double transforming. Oh, the right. We're already assuming where we're actually creating the points when we do this. So we only actually just need to create it and add it. Right, because we've already done the math. We're really telling the server create the bound literally here. It doesn't need to have the transform. Like this will now wrap. So it's cool. This will be a true AABB. So this won't. We won't need to worry about the scale of whatever. If we now look at the code, which is now stupid. It's just literally we could just put this in the add child method and it would just boom. So technically we could feed it. We could do this instead of make a create a debug wireframe cube, and instead of it taking a global AABB, you could take a node reference, right, of whatever it is you want to use as the basis, right, and then it will just kind of like take that mesh instance. That's what it's taking now. It's just a mesh instance is AABB, and then adding it to the scene tree. So some cleanup, and then this AABB can be used for our further testing. So what we'll do is in mesh utils, we'll take this debug let's do I don't want to do it. I don't want to use a singleton. I don't want to use management node of any sort. Simplify all this. So we're using the Godonian space anyway. Let's do but yeah. So all we have to do, we'll do another like static wrapper. So we'll just do like a public static. Yeah, and then we'll do create from mesh instance. And we'll take a mesh instance 3D and a color. And we'll just do what we're doing here. Now you can make that a default. Color must be compile time constraint. Fine, whatever. Can give it a default. I don't think it can be because it must always be of type. You use color. Make it optional. Make it unnullable. Sure. Make it an optional parameter. So create from an instance. Now we have a mesh instance. If it's null, we're returning anyway. If colors can be red, so we have everything. So we can just get rid of this regular reference. We can just get our global ABB and we can pass that. And it's always going to be set, so we'll just cast it back. So we have a mesh instance that we're just going to pass. It's going to be the same code. Ta-da! Alright, so this will match the same AABB the engine's actually creating. But we can now use this AABB as a bound to determine a collision detection. Like a very primitive collision detection, right? So that's the idea, just, right? That's why we can select this thing. I really wish we could keep camera always selected. Sometimes you're testing in a way that you don't care about particular gameplay, like you just always want free cam. And it's interesting that we can't keep this on as a default behavior. You know, when we're trying to do some testing here in the scene tree. Alright, so regardless now we just have our debugs and have these two references. So we're going to create another one for B. So A and B, private instances. And we don't care about this right now, this little cache reference. We can just stick this here and just add them both. I do want to get their AABBs though, but that's let's just render these two debug shapes. One for A, one for B. And let's copy A as B. Test object A. Because what we're going to do, we want to see if we can, determine if a vector transposed locally. Hey, you're back. Welcome back. Right. So we're going to see if a vector transposed locally will be within the AABB bound. Right. So just. Alright, so this one's rendering. We need to set the second one up on our debug. So test object A, test object B. And these will render fine, of course, right? So we have our debug. Because ideally what I like to do, and this is probably a waste, I wouldn't call it a waste of time, but I like to build debug systems as I'm working with something, and I like to make it very specific to what I'm working on. I try not to create crazy abstraction. Like if you know that you don't care about all the child ABBs, or if you just want to see something, you know what I mean? Like you just make a visualization for it, right? Or use I know there's a Godot library which is really good for creating a lot of these, but a lot of times you're trying to visualize something that you're kind of creating. So we have two global AABBs that are being rendered, which is good. And now we want to create a simulation where we create a load of random points and we just render those points. So we're gonna create another visualization of a pixel. Because what we need to do is we want to determine if multiple global AABBs are intersecting, and then B, if I sample, let's say 1,000 positions around an area, I want to render those. You know what I mean? I know you could create a particle too, but we're just, it's totally fine for now. I will want to eventually draw some lines between them, and there's some mental math, something I would like to do with it, which I think would be kind of cool. So let's just do. I want to go better. Maybe a particle. Do I have any debug nodes here? We're going to create a scene, and it's going to be a mesh instance 3D. Yep. And we need a quad. And I want to use the same material for this particular one. I'm probably going to keep it as a class, and it's going to always have the same shared material. Because what we want is billboard to be enabled for this thing, and I'm just going to do a particle billboard, right? So there's just going to be a rendered point. It's going to be 1 meter. It's going to be at the same because it's going to be visualizing stuff in space, so I think this is fine. And then I want to, under my assets, create a textures folder. And I want to get a debug, it's just a regular particle. Just a standard particle texture. Like the OG round, yeah, like one of those. This will be like perfect. Yeah. Yeah, unfortunately we're not doing anything cool tonight, you know what I mean? Or anything, I don't know what productivity will happen, but I would really like to start kind of setting up like a project that's all about spatial, like just the space aspect of it, the universe side, large scale distances. We can do some of the quad tree space, like kind of calculations and maybe some asteroid field stuff, but we're just it's gonna be code that'll be literally able to be pushed into the main repo and we'll have no conflicts, right? It'll be in the right namespaces, right? It'll be like easy peasy, simple, you know, tested stuff. So I'm just gonna save this in my projects, could do universe. Assets, textures, particle single, boom. And we'll use this guy as our albedo. Yeah, and then we'll so let's do a scissor. Yeah. Just for performance issues, because we don't really care. Because it's just going to be a point, really. Technically, that could have been a lot more low resolution. Maybe the fastest. Probably the scissor. I don't think it matters. So shading, we'll do unshaded. Okay. That alpha compression looks terrible. Let me. Yeah, that's the other thing. It's not a great image. Maybe just like scissor it. Yeah, I'm just gonna scissor it through it. The other thing with unshaded is we can't really add emission to unshaded. We'd use vertex colors to give us emission. I don't think this matters. And cool, roughness, metallic. And we want to distance fade them. And we use colors, use data, it's fine. The mesh, the buffer, probably the surface on the target mesh from the source mesh. A dozen of them, random scale, it's fine. So like, these are all little billboard boys. Turn off the original. Alright, so there's two ways I want to render this, right? One is I want a multi-mesh system that I can feed transforms into, right? These are all going to be billboards, so they're no different than a particle system. They're all just the same shared materials, but because I want to be able to draw pretty much this many points, because we're going to be sampling probably like 1,024 transforms or something when we're doing the math on this. But I also want to be able to sample, like draw like make a line renderer that'll take a whole bunch of points and kind of like an array from top and bottom that'll connect those points based on any array. So we just feed it array, and it's funny. It's funny. I didn't turn off. I didn't turn off shadows on the. So it's funny because they're actually casting shadows. It's funny. And we actually don't want them casting shadows, so let's open up the mesh. So because we'll just keep this a mesh instance reference. This will be a little bit cleaner. We won't worry about. Yeah, we actually don't need this scene at all. It's fine. We could just ignore it, and space doesn't need to have it either. Yeah, because the mesh resource has everything we need. Yep. And then in here we can have the material for this. And we want it to not cast shadows. So we don't want it to receive shadows. It's still casting shadows though. Hang on. So like maybe the mesh instance itself is shadow casting. Maybe nothing. Maybe we can't. Disable. shadow to opacity. If true, the shape of the opacity when removed with lighting modifies the alpha. Build where we know is fine. Keep scale. No, we actually want scale to be as it is. Particle animations, glow, transform. Use FOV, use particle trails. Nope. We do want distance fade, but I don't know if distance fade also works with a multi-mesh. So we do a distance fade. And we do it to like pixel alpha. I don't know if this would actually work. So the minimum, maximum distance. Is that camera culling? It's like a view settings. Let's do 128,000. Okay, now that actually is object dither could be cool. Minimum distance from 30 meters. Maximum to 128. Hang on a second. Let's see. Alright, I mean dither. 10, 64. Okay, so that's like the maximum. Oh, so it's not distance fade, it's proximity fade. 128. Kinda. 32. Do they both have to be on? It's like we're getting. Maybe minimum has to be 0. I want the opposite effect. I only want to show ones around me. Maybe let's into the other. No. Oh, okay, I gotcha. Okay. So if this is 32. And this is 0. Okay, I gotcha. I understand. Okay, don't care right now, but I do want to keep that in mind because when I'm visualizing all these points, I would like to move around and not worry about it. So max 256. Yeah, okay, I get how it works now. I'm gonna turn it off for now. It's not important. But I understand. Yeah, I want to regenerate this. Yeah, because when we're populating these are actually just random on the surface. We're going to write code that'll do it. So we're going to create a multi-mesh instance code under debug. And I'm just going to call it debug point visual mesh. This will be a multi-mesh instance 3D. And all it's going to need set transforms. And it can take an array of transforms. I don't know, what the recommendations are so dumb. Yes, the size won't matter. We don't care about that. Yeah, I don't know what. What am I? What is the editor using? I wonder for its autocomplete. I wonder, am I using the new Flash preview? It's really weird because it's cheaper, at least this version of Gemini 3 Flash, but really weird, like ancient, you know, recommendations on the autocomplete. Right, because like this should be transcript 3D. The color format's actually wrong. You know, it's. Yeah, because it should be. I don't even think I need to set the color format. Just the transform format. And we need to know the instance count in advance. Sets a color of a specific instance by multiplying the image existing color, allowing for a different color tinting. Note each component is stored. Really, we can do that? Wait. Does that actually affect the draw calls if you use different colors? How does that even work? Or is it just being done on the render pass? That's interesting. We don't really care about that right now, but you know. And it should be the mesh, you know. Yeah, it's just multi-mesh. And we want to actually, for now, give it a mesh reference. Point mesh, sure. What was that assuming, the class? I forgot the password to make a new share, got locked out, reset the device, and it changed the IP subnets on me. No. Spent the last hour covering my NAS. Oh, and Bix has to go. Bix, thanks again for stopping by. Let me give you a shout out. I assume you stream? Do you stream, Bix? I gotta give Bear one as well. We're gonna snoop on you here. I feel like you would be streaming. Maybe not. Oh, yep. 6 days ago. Bix plays. Yep. If you guys aren't giving Bix a follow, go ahead and drop a follow. I will do the same. Yeah, so this, I like the point mesh, we can now load to the one that we're going to be using with the materials that we're going to be using, and then we'll create a new multi-mesh. We'll set the transform colors. I don't know about use colors being true. It could be cool. I don't know. Like we use instance count must be 0 to toggle whether colors are used. Oh, what? Why would you use a multi-mesh with no instances to be able to use colors? Multi-mesh must be 0. Toggle whether the custom data is used. Oh, because it's in the editor. Right. Because we could do custom data or we could do colors and then we would just regenerate the multi-mesh. Okay. Interesting. So let's clear this. What do I call it? Point visual mesh. No, not feeling that. Maybe it's a debug visual point mesh. Points. Maybe get rid of the, yeah, just a debug points mesh. Yeah. This can be simplified. It's really cool that we can set a whole bunch of random colors. I gotta use the washroom real quick and I'll be right back. So debug points mesh because it's more than one. Why is it? Oh, did the class not change? Hang on. Debug points mesh. Boop. No. I'm creating a multi-mesh. It's going to do it anyway. We'll just bring in our debug point. And the mesh shouldn't need. Okay, so this will be pass. This will be 3D. It's a custom data. If true, multi-mesh will use custom data. Set instance count data. Can only be set when the instance count is 0. Yeah. And what is custom data? What type? Use custom data. What type of custom data would be... Oh, color data. Okay, okay. It's just data in the form of a color. Makes sense. So it's just float for whatever type of data we want. And each number is stored in 32 bits in a forward plus a mobile plus... Okay, okay, cool. So we can use it for whatever we want. That makes sense. And then we can access it in a custom shader using instance custom. Oh, I can see. Okay, okay, okay. That makes sense. I get it. Cool. So we don't need that. So let's just kind of already set up that assumption. Oh, it's when we create. Okay, okay, never mind. And we can set the mesh here too. We won't use data either. So, not important. Just going to create our new mesh and we just use the new. And then that's fine. And we're just going to set our transform, set the mesh, and then we're good. So we don't need to do anything on ready really, other than making sure our point mesh is actually set. So for this debug point mesh, we're going to go into so our debug code that we're testing, it's going to also reference It's so funny. Code autocomplete is wild. That's a normalized double, right? Yes. So here's a point mesh that we just created. It's at the center of the universe. We're going to play. Oh, look. We have points in a cube. Or a visualization of points in a cube. They're pretty big, though, at 1 meter. Especially for... Maybe we're actually not. One thing is important, always use scale, and I think these little guys, these little test objects we made are not very big. yeah, they're 0.5 meters by, yeah, okay, so just, they should be. Much bigger. Closer to ship size, really small ship size. I'm just gonna quickly be like, change the points to random points within a distance. And it's gonna do by, so I don't want to edit that. So they're fine. These are now bigger. Let's move them. Why does it read all this other stuff? When like you're here, you have what you need. I gave you the reference. Like you just need to change this. Oh, because we're in plane, not agent. Right. And then our next line renderer is it's going to be it'll be a multi-line renderer. So a debug multi-vector, maybe multi-line, the 3D lines though. Multi-line mesh. Probably bad, but I think it's fine. Go away. Do I want to also feed it transforms to draw between or vectors? Probably global vectors. Yeah. Public void set global positions. This will take in an array of vector positions and a color. I do like line width. I think that's cool. But like everything, this is wrong because it's old and AI should be like just color, right? Surface color. And it's the same here, right? Intermediate mesh, set surface, surface add vertex, positions I, and then we'll do I+1. Okay, and down. Surface begin, primitive type lines. Oh, for the material. Oh, I can default. Okay. Maybe we can generate the material here in advance. Let's just do new first. Yeah, we don't want this to be null. We want it to be a new standard material. Like everything else, maybe I want to define the material for it. Bum, 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 bum. Yeah, we'll just do this. Color, line width. There's no line width. AI. Shading. Unshaded. Color. Oh, the mission could just be the color. Wait. It's emission strength. Intensity. And the line with doesn't matter because we're making primitives. How'd our AI do? Uses a global position as a center node. Sure. 2/1, red double, it's fine. Okay, so that's all of our random points in a sphere being visualized. Now let's do random nodes being connected. And what would be complaining about? The instance count? Oh, from before. Okay. So we're going to create another mesh instance 3D. This is going to be our debug multi-line. Okay, yeah, multi-line mesh, multi-line mesh. Okay. I think line smash is fine for this name. Connecting A to B, I think is fine too. To be honest, I think it'll work. Just go and throw that reference in there. Lines mesh down. So this should have connected them together with a yellow line. So any random array of global positions. I think it needs like a mission. Like we had a bloom on the world environment node. So I'm not sure if that yellow on the So what we'll do is let's just go through all of these transforms that we created and build up an array of vectors. So just we'll do vector 3 array of line positions. Oh, duh. Alright, so let's create some line positions. And it doesn't need to have initial. And we'll just say for each transform, for each transform and transforms. No, we want to just put them all together and just throw them all in. I don't want 8 all of I just want the transform. Transform origin is maybe just iterate and yeah, just take all the transform origins. What's the difference between a global origin? I'm just gonna turn this into a standard Godot array of line positions instead. I don't think that's needed. The chaos can, it's fine. Maybe not. Yeah, we should use a Godot array for this instead. I don't know which one's faster. I don't think it matters. Because we just have our transforms here. Yeah. That's correct. Yeah, that's right. No vertices were added, so the surface can't be created. Not set when the physical light units are disabled. Oh, because it's unshaded. Okay, just complaining. We can't do unshaded if we're gonna set an emission. So we began with a primitive surface type of lines. Okay. I don't know why I keep saying it's empty. Point mesh is fine. Because we're going to create a new mesh. It could just be an array mesh for the time being. As a default. Not sending the emission. So did the original one work? Let's go back to when we were actually testing this again with the line mesh. Set global positions. I want to kind of use the example we used before. New array of vectors. Updating my service firmware. What's your server? Like just a custom gaming PC? Do you have like some old, we do a range and a dot global position. Just want to do this again and b dot global position. Just make sure it works. Add range. No. Takes two from a 9-year-old collection. Oh my god, here, let's just do array. Just do what you were doing before. 2U Supermicro X9DR 8 3.5 bays. Cool. Yeah, so these are joining. So that works. But just feeding the line positions don't work. Nothing's being connected together. Well, that's not global, but then the origin would be here anyway, so it's weird. I know we're not using color. Shouldn't matter. Positions I for the I plus 1. We get to the end, obviously we're gonna have a problem. But we're never gonna get to the end because we're doing, you know, -1. So we're always going to be connecting our current 0 index to the +1. So it doesn't matter. Let's do 256 points. Eventually we'll start cleaning this up. Just right now I just want to do a whole bunch of random testings. Oh, cool. Take a look. Hey, I like that StarTech rack. It's cool. I have a bunch of HP servers in the basement, but they're too expensive to run. They don't make sense anymore. I ended up kind of buying all new gear. So I have like a 10700K running a load of the VMs, and then a Ryzen, like an older Ryzen, like 3700, two 8 cores. Karina got it for me for my birthday, and the server too. The rack, nice. The rack's good. Those are awesome. Did the server come with Rails? I love, like, I have a bunch of HPs, like, it's a pro line. What do I have in the basement? I'll have to go down there sometime and look through it. But that was the issue I was having. Like, the 2 HPs I have 2 redundant 1000-watt platinums. No rails. Oh, they just held in but bolts. Or is it long enough to be able to reach the back as well? Because some of them have like a static mounting where you can kind of... Or is she just hanging on there? Oh, gotcha. It's on the shelf. Covers the entire box. Cool. Yeah, I want to get a rack, but I think a rack is a gateway drug to home lab, and I'm trying to like minimize everything. Like if I had my way, I'd have like I'd have those custom pictures that are like speakers that are on the wall. Like I want to see no technology. Later on, I think as my next server project, I know you've ever seen the HP Minis, the 600s. These guys, you can get a lot of these now. Like businesses are liquidating older models, but these are really cool, man. The Mini 800s are dual NVMe, and the issue is just finding them. But what happens is in stages, these are wonderful for home labs because they keep getting liquidated. As businesses kind of renew them. These are old ones, but these little things have little VESA mounts, and they're really great little computers, because they have, you can get modules for them, like you can get a 10 gig module. Some of them have full dedicated graphics, but there's always this little module, so you can get like a 10 gig NIC or SPF connector or whatever. Or like a mini NUC cluster. Like if money wasn't a problem, the minis form. The minis form has a new one, like a new. Which one is it? Is it their MS? Is it this one? 99, 10 gigabit. I think it's this one. Like 1,000 Canadian, and you get an absolute beast. Ryzen 9, 99, 77. Yeah. Throw a bunch of DDR. I think this is SODIMM. I feel like they're SODIMM. But yeah, dual 10 gigabit SPF plus LAN, and a full 16x slot. But I would love to minimize absolutely everything to like just these little crazy ultra small slim systems. Mini home lab sounds super fun. But most of my builds are all ITX builds. My favorite build, Bear, which you might like, was back in the Windows 7 days. I had it was a BitPhoenix Pandora, which was like the little Mac clone, a small one. And I was running a Haswell, I think it was a Xeon V3 1275. It was very similar to the 4000 series for Haswell. So I had a really cool, at the time, I think it was a Gigabyte board that had dual network ports. So there was an Intel card and a Realtek card on the ITX board. It had onboard graphics because of the Intel, like the Xen at the time had. What was I using? But either way, that system at the time was running like 8 virtual machines for all my home lab. And then I had it was a Ryzen 7950 graphics card that was passed in as a dedicated box. And I was running Zen back then, so I literally had a perfect Windows 7 gaming rig running fully pair virtualized. So one of the network cards was passed, the USB 3 controller was passed to it, and then my video card and a few other things. I think the Linux computer itself only needed USB 2, right? But it had the Intel card was used for itself, and the Realtek card was used for my gaming PC, and it was literally my whole world in one computer. But eventually, The Sims 4 came out, and for some reason, The Sims 4 would not run on Windows 7 virtualized. It was some weird DRM thing, and I even I had the hard drive at the time set up where I could boot it natively, or I could boot it within Zen, and I could run it natively perfectly. But inside Zen, it would fail, and that's when the start of the maybe we can't pair virtualized stuff. Maybe the DRM is slowly catching up, and then I kind of went dual boot after that, and then never really went back to virtualization at that level. At least for my personal computer. But it's so crazy that, you know what I mean? Like, if you want to run, we have so much extra resources on our systems. There's no reasons we can't be, running hypervisors for everything, and Yeah, I don't know why these are not actually joining. Right, because these are already global transforms, so we can already see that they are. We can see that they're correct, right? Minus 22, 8, 33. These are they all seem they're all within the bounds. And there's only 200 of them, and we should be seeing every one of these connecting kind of iteratively, right? From the order in which they were creating, a line should now be created between them. Because it's add. What? This is the same as a pin with a pushback? Really? That's your solution? Use add instead? Wait, what? Hang on, line positions at a pinned. What's the difference? Alright, append an item. Oh, unless if we're using a pin, we're using... Wait, are we using link? Am I actually using... Oh, we're getting... Okay, I see what's happening. I got you. You don't need to do that. Yeah, that's fine. I understand what you're doing. You're using a pin from Link, which was casting. Yeah, easy peasy, no big deal. So now we have like a line renderer. Like I said, not expecting a lot tonight. We're just building up a whole bunch of debug shit. Right, so we can render some lines, and we'll turn the line render into a multi-mesh as well. But I don't know if that'll work. I think it'd be probably better to just do that one as an intermediate mesh, because we're only going to be using it to render routes. So we have some AEBB rendering. We have kind of like, that's my thought process. I need the tools, because we're going to be writing some probably unit tests to do this. We want to be doing like calculations of collisions and intersections between bounds. Like, the idea is we want to be able to quickly visualize all of these things that we're testing. If we're going to be testing long-term navigational routes, we need to visualize them. If we're going to be testing, how AI is sampling, or how the ship AI is sampling points that are outside of the round to build that flight path, right? And how that is visualized. We need to kind of render it, need to display it. And there was one other thing that I wanted to do, like we're gonna stream. Probably gonna end the stream just a little bit, and I'll probably jump into your Discord if you guys are just chilling. But we need to not just do the approach and the departure. There was something else I wanted to do. Oh yeah, I know what it was. I wanted a sphere shape renderer. If that makes so like we want to build a primitive, similar to like when you're looking at a collision shape. We want to generate a 32 segmented, or we can set resolution. So we can set the resolution as like a multiplier, but we want to generate a sphere with a line mesh that's always facing the camera. It's kind of like a billboarded sphere that represents the detection range of an object. And because it's a sphere, I mean, technically it could just be a one billboard plane that scales up, but it depends on how I want to do it, right? It could be it could literally be a plane that creates a shader and it does like a UV clamping, smooth step, whatever. But those are the things we need to visualize. A shape, a distance. I could add like a fulcrum, visualizer, but we won't need it. It's just going to be like, just a bunch of other stuff. And then my goal is do some cleanup of this debug, move it all into like I have a mesh utility script, but I want to create like a uniform debugging visualization system on all of this, and then backport it into the main project, because the main project does have a bunch of these, but they're kind of nodes. They're not like they have like a wireframe debugger, and you add the node and it looks for the parent and it sees if it has a collision shape and it creates it. It's too general, too specific, and I want to create a more generalist debug library where you can, it's not assumed what you want to debug. It's not assumed that you're trying to debug the bounds of a collision shape. This is just kind of like, hey, I got some data, I have an AABB, right, which you could encode get from a collision shape or vice versa. It's not like the library, this debug library only needs to work with positions, rotations, bounds, and do everything based upon those properties. So it is 12 o'clock now my time. I'm going to end it here on YouTube. I'm going to go find some of the raid. Make sure as well